today my talk is going to be about, thank you, design for patient safety. I'm going to talk a little bit about who we are, so where I work, what we do. I'm going to talk a little bit about design for patient safety, so exactly why we need to be doing what we're doing and the different issues that we face. And then I'll talk you through a few case studies, 3 case studies, and then at the end, hopefully, we'll have time for some questions. So who we are. I'm based at the Helen Hamlin Centre for Design, and that's at the Royal College of Art. And the Royal College of Art is a wholly postgraduate college for art and design. And we take students who have already done a degree, and they cover a number of different specialties like architecture, product design, interaction design, communications, and so on. So a broad range of disciplines. And at the Helen Hamlin Centre for Design, we take graduates from the Royal College of Art, so this is post-masters graduates. And we typically give them work to do for a year or maybe 2 years in a project specifically aimed at inclusive design, so that's placing the user at the heart of the research and the design process. And they would work for a year or maybe 2 with an external partner, so an industrial or somebody from the charitable sector on a specific design project. And our work is grouped into 3 themes. So there's the age and ability theme, so that's looking at the aging demographics, so how as the population gets older, what demands that makes on the design of products and systems. There's the health and patient safety lab, which is where I work, and I'll talk obviously a little bit more about that. And then there's a work and city lab, which is focusing exclusively on the design of the workplace and cityscapes. This website, designingwithpeople.org, is a really good resource for the sort of things that we do. So every method that we've developed at the Helen Hamlin Centre for Design, we post up on designingwithpeople.org. And this is a resource for designers to go to learn about the different methods that you can use to engage with users and frontline people in the research phase, try to get as much relevant information out of them as possible. And then in the design phase, so try to involve users in your design process. And that obviously means going out of the studio and talking to people in their context. So it might be in the domestic environment for a product or a system or a service designed for people's homes. Or it might be going into hospitals, which is what I do quite a lot. So we speak to people on the front line, doctors and nurses, as well as other people supporting, so porters and cleaners, and perhaps most importantly, the patients and their relatives. So designing for patient safety, why do we do it? Why do we need to do it? Well, this is quite a good example. This is on a typical regular hospital. You can see a number of different signs. This confronts the patient or the relative as they enter the corridor before they get to the ward. And you can see that each individual sign might be fairly well designed. They might have thought, I'll use this size font and I'll use this many words. But it's the implementation that is the problem. So you see there's just a confusing mix of different signs. And it means that as soon as you get to the corridor, you can't really see what's going on. You're bombarded with information. And actually in the center there, you can see there's the hand gel dispenser. So this dispenses alcohol gel to clean your hands, which is a very important bit of equipment. But it's not immediately apparent that that is there. But if that's just in a corridor, think how much more complicated it gets in the operating theatre, where you have a mix of different processes going on, different people, different team dynamics, and obviously different pieces of equipment to be used. All with different interfaces, and you can see that the opportunity for design to create error or to create a safer environment, there are many opportunities there. One of the most famous examples is in 2001. There's a case of a patient who was expected to make a full recovery, but during the course of his treatment, he was injected with a drug called vincristine. The prescription was to inject this drug into the patient's veins, but the mistake was made, and the drug vincristine was injected into the patient's spine, and shortly after the patient died. And an investigation into this incident found that the design of the syringe and the needles was partly at fault. It was the syringe and the needles were designed to be interconnectable, so you could connect the syringe of vincristine of different concentrations. You could attach that to a syringe to go into the vein, or just as easily a syringe to go into the spine. And this meant that this interconnection meant that it was very easy to connect the wrong thing and to inject into the wrong place. And what's perhaps the saddest thing is that this lesson had already been learnt elsewhere in healthcare. So these are connectors for an anaesthetic machine. And you can see that they don't connect together. They're designed not to connect together. This is for an anaesthetic machine, where the purpose of the machine is to mix different concentrations of different gases throughout the operating process. And it's very important not to get it wrong. So they have different color connectors for the different gases, and obviously the different connectors cannot physically be connected together. So the lesson had already been learnt very substantially in the operating theatre. The question was, why wasn't that lesson applied to the vincristine incident? Why did that accident happen in the first place? In 2003, at the centre where I work, at the Royal College of Art, together with the universities of Cambridge and Surrey, we produced this report, the Design for Patient Safety Report, which investigated how the National Health Service in the UK uses design. And it said a number of different things. There's a fantastic quote here from Professor Lucian Leap, which says, human beings make mistakes because the systems, tasks and processes they work in are poorly designed. Among other things, the report found that there's no systematic feedback between users, purchasers, designers and manufacturers of equipment. Therefore, opportunities to reduce risk through better design are being lost. The point is to try and get everybody working together so that everybody understands different stages of the development process. The designers experience the problems firsthand and they understand exactly what it is that they're designing for. So this led to a number of different projects where I work, and I'll take you through. There's 3 case studies I'd like to talk to you about. So this is the first one. It's called Design Bugs Out, and it was a project with UK Design Council and the Department of Health. And the brief was to investigate how design could improve the cleanliness and prevent the transmission of infection from one patient to another. I don't know about here in Poland, but in the UK, they kept on hitting the headlines that hospitals were dirty and that patients who were receiving were getting infections. And what's more, the infections were bugs that were resistant to antibiotics. So the problem was quite severe. People were dying. So we did convene a group of designers, lots of frontline healthcare staff, engineers and so on. And we visited 7 showcase hospitals across the UK. And we gathered a number of insights just from visiting them. And we explored the spaces ourselves, just trying to understand the basics of the hospital environment. A lot of the designers hadn't been in the hospital environment before. And we also shadowed different healthcare professionals, observed what they do, and did lots of informal interviewing to try to understand the problems that they face. And we took all this information from the practical research and combined it with desk research. So we were looking at all the latest papers about infection control. And then we convened a workshop of different experts in microbiology and other healthcare experts. And combining these 3 sources of information, we arrived at design briefs. So there were 11 design briefs, and 5 of these went to external partners, but 6 of them we took on ourselves. So these are 6 designs that came out of the place where I work, the Helen Hamlin Centre for Design. I'll just talk you through them one by one. The first is the blood pressure cuff. So you might have all seen it. It fits around the patient's arm. And the problem is that it should be cleaned between patients, but often it's not cleaned, it's not wiped down. And a lot of the reason for that is because it's very difficult to clean. It uses Velcro to attach the cuff to the patient. And Velcro is very absorbent and can get wet very easily and doesn't dry quickly. And it creates an ideal habitat for bugs to breed. So this was our solution. We took exactly the same mechanism of measuring the patient's blood pressure, but instead created a vinyl sleeve for it, and it's held in place with magnets, so it can be wiped clean very easily, and there's no Velcro to make it difficult to clean. Instead, it's very easy to wipe clean. The next is the pulse oximeter. So this is something which fits on the patient's finger and measures the levels of oxygen in their blood. You can see that the existing design is a complicated assembly of lots of different components, and there's lots of little spaces there for dirt to get trapped. So our redesign was a simple one-piece mold made out of silicon, so it's easy to wipe clean, and it keeps all the electronics in there. Looking at the curtains, there were a number of different things that we found. I'm going to see if I can play this video. So, okay. I'll talk you through it. So we designed this this handle, which slides on the end of the curtain. The problem beforehand was that curtains can be grabbed at different points, and it's very hard because the curtains are flexible material to clean them. So we designed this curtain clip, which provides a rigid handle, so you can clean the curtains down. We also put some magnets in the handles, so that when you draw the curtains, you get a proper seal, and this improves patients' privacy and dignity. The next brief was that of patient hygiene. So that is, we were looking at how the patient interacts with their own environment, and we found that there is very little control that the patient has over cleaning their own environment. So, this is working now. So we repackaged, you might have seen these normal Clinell wipes, at least they're called Clinell in the UK. Lots of wipes are everywhere on the hospital ward, but they're usually facing the healthcare staff and aimed at them to clean equipment. So we repackaged them and made them more patient-friendly. So we put some more patient-friendly graphics on the front, and we provided them with a little hook so that they can be hooked anywhere within the patient's space that they have. They can take control of the cleanliness of their own environment. Looking at invasive procedures, so this is when you insert a needle into a patient's arm. Often the problem is that these needles shouldn't be left in for more than 3 days or 72 hours. But the problem is that when you insert the needle into the patient's arm, people are supposed to record when that needle goes in, but it's difficult to tell if you're just visiting a patient to see how long a needle has been in the patient's arm. It's often noted down in the notes somewhere, but nobody ever reads them. So it's difficult from just looking at the needle to see how long it's been in and if it needs to be changed. So our solution was to borrow technology from the food industry. So this this blue thing you see there is called a time strip. And so when you put the needle into the patient's arm, you press that dark blue button, and that breaks an ink capsule. And as soon as the ink capsule is broken, the ink starts to move up the white window that you see in the middle. And by the time it reaches that line, you know that 3 days has been reached, and it's time to change that needle. Finally, this is probably the most disgusting of the briefs, but it was looking at the mattress. So the problem with the mattress is that even though it has a waterproof surface, sometimes needles or scalpels will pierce that, and then bodily fluid will get in. And so the inside of the mattress can get really dirty and disgusting, but there's no way of telling from the outside that that's what's happened inside the mattress. The only way they can tell is every year there's a team that goes around the hospital and opens up the covers to see which mattresses are disgusting and which aren't. So we'll see if I can do this video. Oh, so close. Is it working? Yeah, it's going out. So yeah, we were looking at the mattress itself. We were looking at the layer, the waterproof layer. So at the top you have some transparent polyurethane. We put a layer of hydrochromic ink just underneath the waterproof part and above the foam. So that means that in the scenario that I told you about, when a needle might pierce the waterproof layer, and then some bodily fluid might drop in, like so. The hydrochromic ink that we've put in there changes colour, and that means that you can see that there's been a compromise when you're changing the bedding, and that you should change the mattress. It should be thrown away. So those 6 designs that I went through, they're in various different stages of the commercial development, and we prototyped them all and took them around hospitals, and by and large, a lot of the frontline users really, really like them. So that process is still ongoing. The second case study I'd like to talk to you about is resuscitation. So this is a redesign of the resuscitation trolley. And for those of you that don't know, this is what happens on a resuscitation if this video works. It's going. So if you're in hospital and your heart stops, hopefully someone will notice and they'll put out a crash call. And different members of a crash team will arrive on the scene and they'll do different things. So they'll give you oxygen, they'll try to restart your heart, they'll give you drugs and so on. And all the equipment that they use is stored on the crash trolley or the resuscitation trolley, which you see at the top right there. The problem is that the crash trolley has problems inherent in the design. There was a study in 2005 which showed of 86 incidents involving crash trolleys, 13 described harm to the patient and 10 reported the patient's death. There's a number of different, more recent studies which back up this finding. So again, in the spirit of the Design for Patient Safety report, we tried to collaborate with lots of different people. So there was designers from where I work, there was clinicians and frontline staff from Imperial College London. They have 3 large teaching hospitals in London. There's the National Patient Safety Agency in the UK NHS, which provided the money. And later on, we involved a manufacturer called Bristol Made. And the first thing we wanted to do was to try to understand the product. So here's a selection of existing resuscitation trolleys. A little bit about the history. They were first put on a ward in the 1940s, and resuscitation, or CPR, was first described in the 1960s. And since then, the science of how you resuscitate somebody has come on leaps and bounds. There's lots of technological advances, but the design of the crash trolley, or resuscitation trolley, hasn't really changed. Because it's based in the 1940s, it's actually based on a mechanic's tool trolley. So of these selection of trolleys, you can see that these are actually mechanics tool trolleys. So you can see just how close in design terms a resuscitation trolley is to a crash trolley. And when you go onto a hospital ward, often you see something like this. The trolleys become a bit of a dumping ground, so everyone just puts things on the trolley just to be on the safe side. They try to load it with as many things as they think that you'll need in a resuscitation attempt. But the problem is it becomes really messy. So you can see there's a tangled mix of wires and cables, and you know in a pressured resuscitation attempt, like this is, it's difficult to get what you need because the trolley is all closed. It takes the doctor in the top left there, I think it's 6 separate attempts and 18 seconds to find what it is that he needs. He's got it. That's a simulation, so don't worry. So we were looking at the product of the resuscitation trolley, but we also crucially wanted to understand the process of resuscitation. So as designers, we didn't know anything about resuscitation. That's one of the things we bring is ignorance. We started off by reading the relevant literature about resuscitation, trying to understand the science behind it. We interviewed different team members to try to understand their perspective. We attended advanced life support courses, so that's we were learning ourselves how to resuscitate somebody. And of course, we attended actual resuscitation attempts. And through all these data sources, we tried to map out the process of resuscitation and all the different things that interact with it. It's quite a long and complicated system, so this is just a selection. And then working with frontline staff, so resuscitation officers, doctors and nurses, we came up with a whole load of weird and wacky ideas. And then we eventually took them to other people and got their feedback. And we narrowed that breadth of ideas down into one specific solution. So this is the first prototype of the resus station. You can see it's quite a departure from the original resuscitation trolley. Everything is laid out openly, so you can get things at a glance and take things without having to open drawers. And the unit itself is split into 3. So on the left you have breathing equipment, so masks and tubes to help the patient's breathing. On the right there is intravenous access, so all the needles and fluids you need to resuscitate somebody. And in the center you have miscellaneous equipment like gloves and suction and so on. And actually this trolley splits into 3. So if you remember the animation that I showed you earlier on, where different healthcare professionals were standing around different points in the bed, these people can take their sub-units. So the left-hand side of the trolley would detach, and the person managing the airway could wheel that to the head of the bed and just be in charge of their own equipment. So it facilitated team working. The design won a number of different awards at that prototype. And then it was at that stage that we involved the manufacturers, and we went through the next design iteration. So we had an opportunity to redesign this, so we took it back to frontline staff and got their feedback. And there are a number of things that were wrong with it. Firstly, the splitting mechanism wasn't good enough. We had to improve that. There was an issue of security, so having everything laid out open meant that when the trolley isn't in use, doctors and nurses would just take things from it because they couldn't be bothered going to the proper storeroom. And then there was a few problems with the layout, so we needed to just move a few of the pockets around. So this is the redesign done with the manufacturer, so it's all made in pressed sheet metal, quite boxy looking, quite heavy, but much more robust. And you can see that it splits there. The splitting mechanism is mechanical and pedal operated now. And we've also color-coded the different units, and this follows the accident and emergency color-coding system. And that's gone through a number of trials at St Mary's Hospital in London. So that was trialing it in simulation, but also in real life. And it's quite nerve-wracking when you're a designer, having your prototype being put in the situation where someone's life is in the balance. But thankfully, there were no incidents as a result. So the final case study that I want to talk you through is the DOME project, Designing Out Medical Error. So this was a 3-year project, so much bigger in scope than the previous 2 case studies that I've told you about. And this was looking specifically at improving patient safety through design on hospital wards. Again, patient safety was never far from the headlines. There's been a number of incidents in UK hospitals, and the press love to talk about it, and the issue of medical error and patient safety is rising up the political agenda as well. And there's been international studies which have shown that 1 in 10 patients admitted to hospital will suffer some sort of adverse incident during their care. So it's an international problem. Again, looking at the design history, here's a shot from the 1940s. The ward, this is at the start when the NHS was first started. You can see that the layout of the ward follows a nightingale pattern. So that's, you have a clear corridor and lots of patients' beds next to each other facing the corridor. So that was a shot from the 1940s. And this is a shot from a few years ago. And you can see that although technology has come on a lot since the 1940s, obviously, there are certain fundamental design principles which is still the same. And we wanted to see how design could make a practical difference in the everyday processes that occur throughout healthcare. So again, we convened a team. So there was 2 designers from where I work. There was doctors from Imperial College and psychologists as well this time, and also business academics from Imperial College London Business School. And I'll talk a little bit about that now. The remit of the project wasn't, one thing we weren't doing was looking at emergency care. So we were looking specifically at elective care. So that is planned visits to hospital. So someone coming in for cancer surgery or something where the process should be known and well mapped out. So as a collaborative team, we spent the first year of the project continually shadowing patients through their journey. And we mapped out their journey. So we wanted to see all the different environments that the patient visits through their journey from admission through to discharge, through the theatre and through the ward as they recover. and all the different people that they interact with as well. And this led to this common platform. So this year-long process of looking at the journey through the hospital, that was context. We used that context for more focused work on a hospital ward. And then we used the ward research as context for more focused work on the bay, so that's a collection of 4 or 6 beds. And then finally, the most focused research was done in the bed space, so the space immediately surrounding the patient when they're in bed, which is when they spend most of their time. And we tried to learn lessons from different industries. So different risky industries like nuclear, oil, mining, and so on, they have very robust procedures in place to try to manage risk. We wanted to see how we could take processes from those industries and apply them to healthcare and also to the design process. So the first thing that we did was to take a rather basic scoring system, how you rate a hazard, and try to apply that to basic healthcare processes. So we triangulated a number of different data sources. First of all, there was the observations at the bottom left. That was our own work going through the hospital following patients. Then there was incident data. So there's a whole load of data every time, well, it should be every time, but whenever something goes wrong in a hospital, the incident is reported. So there's a data source there. And then finally, there's questionnaires that we issued along the lines of the taken from the other industries. So we issued these to healthcare staff, and we combined this data with our own from observations and incident data. And we came up with this, which is a very rough first phase of the research. So this was assigning a rough hazard score for each of the common bedside processes. So down the left is the typical things that happen at the bedside, and across the bottom is the average hazard scores. And you can see that we used a cutoff of 9, and anything scoring 9 or higher, we classed as a risky process, and we took that further forward for further research. So the things that we took forward were hand washing, observations monitoring, so that's the measurement of blood pressure, temperature, and so on. Isolation of infection, so that's trying to stop the spread of bugs from one patient to another. So using aprons and gloves and using the hand gel. Medication delivery, so giving drugs to a patient several times a day. And staff handover, specifically when the night shift leaves and the day shift arrives, how you transfer that information so that no information about the patient is lost. So looking at those 5 processes, we wanted to find out exactly where was going wrong in much more detail. So we followed each process in much more specific and focused detail. So I'm going to work through the hand hygiene, the hand washing pathway. So we followed someone and observed how they clean their hands, which is a really basic thing to do. But we started to map out exactly what happens when you clean your hands, and we did it in really pedantic detail. And it might look really almost too specific, but it's actually very important, these different points. So this is just a selection of a much broader process. But you can see at the start, there might be, see at the bottom left, remember to decontaminate your hands, and then the next step is decide to decontaminate your hands. And they're subtly different points, because you might remember to do it, but think, I don't have time, or I can't be bothered, and just don't clean your hands before you touch the patient. So mapping this thing out in very detailed steps, we then approached an expert in each of the processes, so in this case the hand washing expert, and made sure that they thought that this map was correct. And once we had that correct map, we then performed a failure mode and effects analysis. So this might be familiar to the engineers, but I'll just talk you through what we did. So once we had this map, we then gathered a small group together. And a small group in this case consisted of a doctor, a nurse, a patient, a process expert, so infection control expert in this case, and one of the team as a facilitator. And they were asked to consider each step in the process that I just showed you in turn as a group. For each step, they had to consider 3 things. They had to consider severity, so how bad it would be if this step went wrong. Frequency, how often this step went wrong, and detectability, how easy it is to pick up if this step has gone wrong before harm happens to the patient. So these are the scores: severity, frequency, and detectability. And for each step, so they needed to give 3 scores between 1 and 4, and the team had to reach an agreement to assign a score in each case. And then for each of those steps, you then multiply each of these 3 scores together to give you one final score per step. So in terms of the hand washing, remember the first step of remember to wash your hands. The severity score would be 4, because it might be that if you don't clean your hands, you transmit an infection to the patient and the patient dies. That is a realistic scenario. Frequency, again, it would score 4, because hand washing rates are traditionally very low. Compliance isn't very good. And then finally, detectability. It's very difficult to pick up if someone hasn't cleaned their hands. I mean, I haven't used hand gel, but my hands look clean. So in this case, it would score the maximum, which is 4 times 4 times 4, which is 64. So each of these steps, which scored the maximum score, were then placed back onto the map. And you can see in red, that's where the real bad things are happening. And that's actually where you should target your design work. So it's quite a good way of being thorough about it, but trying to target what your intervention is going to be looking at. So having performed this research, we started to develop this into a series of design briefs. So we involved the clinical side of the team in the brief definition phase. And this is the final video. Hopefully this is working. Yeah. So we started to put all our initial ideas onto the initial brief and then group them into areas. And this led to a much more specific definition of what each brief would do. But in essence, it did boil down to focusing design work on each of the 5 processes. So just to recap, they were hand washing, isolation of infection, so the use of aprons and gloves, vital signs, so monitoring blood pressure, temperature, and so on, medication, and handover. And we came up with a number of different ideas. This is the process that we went through. So even before we started to sketch out the different ideas, as soon as we had something, we just wrote it down, just the text, and then took it straight away back to the ward to find out what it was that they thought of the idea and how it could be made better. And so this slide shows the breadth of ideas. So a whole load of ideas on the left-hand side there. We then took it back to the ward. Some people thought the ideas were great, some people thought they were rubbish, and we wanted to make sure we focused on the ones that were good. So we discarded a lot of the rubbish ones and took the better ones forward, made them a bit better, so sketched them up or started to make models of the idea, took them back to the ward, refined them again, and it's through this process that we discarded the poor ideas and focused on the better ones. And this led to 1 or more interventions for each process, and I'll talk you through them now. So looking at the medication brief, so that was the administration of drugs throughout the day to the patients on a ward. And we noticed that often patients are given their pills in a blank paper pot, and their blank pills put inside are often white pills in a white pot. So an elderly patient wouldn't even be able to tell how many pills they had in their pots, and they certainly wouldn't know what it is that they're for. And often patients can become mistrustful and not take the drugs because they think that they're the problem. So we wanted to involve the patient a lot more in their medication regime. So our solution was to redesign the blister pack. So you're familiar with the regular pack that you pop pills out of. We redesigned that so that the blister itself is a series of 7 tear-off strips. You can see on the left there. And each strip takes the form of a spoon. So the tablet is in one end, and the handle of the spoon provides a nice large area to write lots of patient-friendly information on. So it shows what the drug name is, the strength of the drug, what it's for, and any side effects that they might experience. And of course, patients might be on more than one drug. So instead of the paper pot with lots of different pills in, the patient might have a tray that you see in green there, where you can put these strips or spoons onto the tray, and then the patient is presented with their own collection of medication with patient-friendly information on it. Looking at the vital signs brief, this concerns the vital signs trolley, which you may or may not be familiar with. This is wheeled from one patient to another to measure their blood pressure, their temperature, and so on. And there are two issues with this. The first is cleanliness. So again, it's a tangled mess of wires and cables, and the basket is very difficult to clean. And as a consequence, it's very rarely cleaned between patients. So infection control is one thing. The second thing is the management of information. So using this machine, you can get a reading for blood pressure, and then typically the nurse would have to plot that blood pressure onto a chart. The problem is that the nurse might plot it incorrectly, or might plot it correctly but take the wrong action. So the management of information was a big deal. So our solution was a redesign of the trolley. So instead of the basket, you see there's a central unit, which is very easy to wipe down. We've put wipes on the front. We also used our designs from the previous Design Bugs Out project. So the blood pressure cuff that was easy to clean, and the finger clip we've also put on there. And we put them on retractable cables. So the cable moves back into the unit, so you don't get a tangled mess of cables, and it's not too difficult to clean. The second point was we put a flat screen on the trolley, and this automatically captures all the patient data and plots it. So there's no transcription error, and also it can calculate the modified early warning score. So this assigns a score to each patient, and depending on the thresholds, it will recommend different actions. So go and get help, or increase the observations frequency, and so on. Looking at hand washing, this was a similar problem to what I showed right at the start of the presentation. There have been a number of different campaigns to raise awareness of hand hygiene, but their implementation was really poor. Often they would target you as soon as you walked into the hospital ward. You'd be bombarded with information, and so much so that it might hide the actual hand gel dispenser. But what's more important, perhaps, is cleaning your hands at the bedside, so before and after you touch a patient. So we wanted to focus our attention there, and we wanted to get rid of all this visual clutter. So again, we took lessons from another industry. In this case, it was the construction industry. They had a similar problem of getting their workers to wear the hard hats or the helmets. And they had a simple icon of hard hats, and that transcended lots of different languages and was very easy to read. So we took a similar approach, did away with all the different posters, and just had a simple icon for hand hygiene measures, which you can put at the relevant points where you actually do need to clean your hands. Looking at handover, this is the transfer of information from the night shift to the day shift. So there's a large collection of healthcare staff talking to each other about the different patients that they're going to experience that day. And there is lots of work done in the handover process, so how you do that properly. But there's not so much work done in the environment in which it happens. And it often takes place in a staff room, which is really poorly designed for it's not fit for purpose. It's often too dark, it's too noisy, it's too warm. There's not enough seats for everyone to sit down. There's not enough places for people to read and write documents, and they often get interrupted. So we wanted to use existing designs, off-the-shelf objects, and redesign the staff room space. So we realized that space is at a premium in a hospital. We're not asking for a new handover room, but we are using existing products to try and just transform the room and make it flexible. So this is the room in staff room mode. So you have lots of comfortable seating, nice relaxed lighting. You have a kitchenette and a TV. But then the space can be adapted. So you can have more focused task lighting. You could have fold-out seating, so there's enough seats for everyone, more appropriate seating and enough space for everyone to sit down. The kitchenette can fold away, and the TV can display patient data. And there can also be a do not disturb sign outside the handover room. So it's really basic stuff. There's no design genius here. It's just the implementation of correct design principles. So the final brief that I want to talk to you about is isolation of infection. So that's the use of aprons and gloves. And we found that healthcare staff, they come to the patient's bedside to do a clinical task. They come to take blood or give drugs or do something they consider very important. What they don't come to do is put on aprons and gloves. They see this as a barrier. They just want to get on with their job. So we wanted to look at the typical processes that happen around a bed space. and we found that it's really poorly provided for in design terms. So if you wanted to give a patient some drugs, you'd have to get to the patient medication locker, and it's often at the head of the bed, and often has a fairly immobile patient sitting in front of it, so it's difficult to get to. If you wanted to use a scalpel or a needle, you would have to dispose of that safely, so you'd have to take a sharp spin, but there's nowhere to put it in the bedside, so they often just put it on the patient's legs, which isn't very safe. If you wanted to use gloves and aprons, you'd have to go back out into the corridor to get them. And there's no flat surface for reading or writing documents, so often you see doctors holding the patient's notes, and because their hands are full, they don't clean their hands. So we did all this technical research, and then we found that a patient just summarized it really well in one sentence. He said, "That's all you see, isn't it? People running from one side of the bed to another, saying, 'Get me this, get me that.'" So we thought it'd be really great if there was a one-stop shop, so somewhere in the bed space that had all the equipment that you need for common bedside tasks. And this is the first prototype, so this is called the Care Centre. Working with doctors and nurses and patients, we decided what would go on it and where it would go in the bed space. So this hooks over the end of the bed, and it has 3 sizes of gloves and apron. It has somewhere to put your sharps bin. It has wipes for cleaning equipment down between patients. It has the alcohol gel in pride of place, a flat surface for reading and writing documents, and the patient's drugs locker. And we took this round over 100 different healthcare staff to get their feedback. And there are a number of things that were wrong with it, but there are a number of things that were right with it as well. So this is the second prototype. You can see that it's now freestanding. One of the problems was that if it was hooked over the end of the bed, patients get transferred around hospital. So these units would get transferred around hospital, and it'd be difficult to keep track of what was where. So the unit became freestanding. We also added a clinical waste bin for the safe disposal of clinical waste. So this is the third prototype, exactly the same design principles, we just shrunk it down so it's a bit smaller and easier to clean. And this is me being a patient. We trialed this design in simulation. So I pretended to be a patient, and volunteer nurses came to the simulation ward, and they pretended to take my blood pressure, give me drugs, and remove a needle from my arm. So typical healthcare processes. And we videoed them as they did this, and we plotted their footfall. So on the left you see this is without the care centre, without the intervention, and you can see that the nursing walking pattern is scattered all around the room because they had to get certain bits of equipment from different places. And you can see on the right, that's with the care centre. So that's much more focused around the patient's bed, and it makes not only the process more efficient, but they tend to stick to correct procedures more. And as well as doing a simulation, we trialed these in real life. This is quite a basic prototype, but you can see, you get the idea. There's a whole bay with these units on. And the real life trial also showed that it improves efficiency and improves infection control. And this is the final design. So there, you can see that there's a few compromises made aesthetically, but now it's made at a certain price and is on sale throughout the UK. So that's all the case studies. Just like to leave you with one conclusion. This is how typically medical device design is done. It's often a bit like a relay race. So the doctor might identify a problem and do some research, run the first leg of the relay, and pass the baton on to a designer. So say, this is the problem. And the designer hasn't seen the problem firsthand, but then the designer would run their leg and do their design work, pass it back to the clinician or a psychologist to do proper clinical trials. Then they would pass the baton on to a manufacturer. And by the time the object or the design gets back into the clinical space, it's not what the doctor wanted in the first place, because every time the baton is passed on, there's an opportunity to misunderstand things and to lose information. So what we see is it's more like a rowing boat where everyone's in the same boat. So although the clinical part of the team are leading and teaching everybody else how to do clinical research. Then during the design phase, the designers lead, but they also involve everybody else in the design process. In a similar manner, trials are conducted and everyone has a say in how the thing is manufactured. So by the time the thing does get back into the clinical space, it is what people wanted. And the trial results are showing that that process works. So that's all. Thank you very much. And time for questions. There's one question there.
Hi. I really like the designs. It's a set of brilliant ideas, really. And what I was about to ask is, could you comment on how the ideas get crashed onto the wall of practical application and money that follows? I mean, I really like the pill dispenser, you know, the spoon-shaped one. But it seemed that the plain cup costs like 5 cents to produce, but the spoon-shaped container with a dedicated tear-off lid with inscriptions seems like something that's much more expensive. And could you comment on how that's how that's working?
That's those interventions that I showed you, the 5 ideas coming out of the Dome project. They're all done to various different levels of development. So the last one, the care centre, that's now in production. We made all the financial cases for it. So that's the gold standard of how you translate research from initial research question through to real life product. But as you correctly identified, there's a whole load of real world issues which prevent you at each case. But there are a number of different ways of tackling that at each case. So the gold standard would be to think of all the financial implications and make the business case for each design as you go along. But we couldn't do that for everything. We didn't have enough time. We didn't have enough resource. So what we thought we would do, we would leave certain designs at certain points in the development phase. So the medication thing that you looked at was the earliest we dropped the idea, if you see what I mean. We didn't take it all the way through because there are clearly cost implications. I know from a past project how difficult it is to get production lines changed. So this was intended more as a discussion piece. So it's through the promotion of the design. If there's a huge user case behind the design and people can see the benefits of it, merely prototyping it and then showing how people like this idea, the promotion of that and creating a discussion piece around it was the intent in this case. So it wasn't to get through all the way to manufacture, but it's a way of engaging manufacturers. So they might say, we couldn't possibly do this, it would cost us millions of pounds. But they might say, we could adapt it in a certain way based on what you've said that would cost us less. But you're right, the financial case in that project needed to be made much more strongly.
Okay, thank you.
Czy jeszcze jakieś pytania? Okay. Oh. 2 more questions.
Great talk, Jonathan, thanks. I was wondering a little bit if you may be oversimplifying things. I really loved the clean hand icon, but you only showed one dispenser. Like in my hospital, we got at least 3. There's like alcohol, gel, disinfectant, non-alcoholic one, and 2 different moisturizers. Now, the icon looks aesthetically pleasing, but aren't you running into the problem of having to re-educate your medical personnel which one means what?
Yeah, that is the problem. The problem we found was that the promotional or the campaigns to raise awareness did their job, but now people know about the need to use the alcohol hand gel. So that job is done. So we have to shift from campaigns to simple icons or simple the denoting of different points at which you need to clean your hands. So we were following the World Health Organization 5 moments. So before you touch the patient, after you touch the patient, after contact with bodily fluids, after contact with the patient's surroundings, and before and after entering the ward and after leaving the ward. So it was more points in the process that we were trying to do. But I appreciate that the process is complicated. And also that sometimes you need to clean with alcohol gel, sometimes you need to clean with soap and water.
Thank you for a very extremely interesting presentation. For me, it was the more interesting that you show that in medicine, if we add one task to another task, that sometimes we obtain difficulties, we obtain crazy, dangerous process that after ergonomy analysis that we obtain only when we one task to add another task, we have one task. That is the really success. But my question is another. What's your opinion about the American design versus European design? When I remember Steve Jobs when he prepared the Apple design line, he looked for instance brown products or another European products. What is your opinion about European and American design?
Thanks. It's a very difficult question. I wouldn't say necessarily that there would be a distinction geographically in design approaches, but what I would say is the context, particularly in design and healthcare, is very different in the US. Because of the way things are funded, I won't get into the complexities of the funding of the US health system. But even in the UK, speaking specifically about the UK, one of the main problems is that the purchasers of equipment aren't necessarily the people who use the equipment. So even if you design something which is so great for the frontline staff, you also need to, it's a little bit about your point earlier, you need to make sure that you design not only for the frontline user, but also for the purchaser. You have to make financial sense for the person who's buying it, and that can obviously have a impact on the design process. And in the US, the relationship between the user and the provider and the purchaser of equipment is something which I don't fully understand, and I'm barely even understanding it in the UK. So, yeah, it's a difficult point. But I would say that those were the drivers of the design process rather than geographical or cultural, because money talks, and I think that's the thing that, in the end, you need to get your design bought and implemented that way. So how you do that differs in the US to the UK and Europe, but I'd say those were the drivers.
The evolution in Europe was longer.
The what, sorry?
The evolution of culture in Europe was longer.
Yeah.
Okay, czy jeszcze jakieś pytania? Okay. One more question.
Hi, thanks for your great case studies. I got a question about these designs, because as I suppose, not every of these designs were implemented, right? And they were made in a commercial way. Like, did you did it for some company or something like this? Because what would you think about, for example, if someone would use your ideas to actually implement the real products? Because, you know, you were doing it for some organization, hospital or someone, and as I understand, someone got the copyrights for the ideas and for the designs. And as I understand it, it's also for the public health and, you know, the human wellness and so on. So is it okay for someone to use your ideas or your designs to actually implement it?
The way we work is a number of different ways. So I showed you 3 case studies that were pure research. So they were Research Council funded. So they didn't have a commercial agenda from the start. There are other projects that we do carry out for companies. So they follow a much stricter approach to the intellectual property. But that said, we're still learning. We're not experts at all in how you implement. So you might recall on the Design Bugs Out project that I showed, the idea with the cannula, with the little button that you press. After the end of the project, there were other people who were implementing it as part of the project, but we did find that there were other people stealing our design. But because the project had finished and we'd already assigned all the intellectual property to the client, we thought that's fine. You know, it's good. People are using it, so it's of benefit. And obviously, we're flattered that someone's taking the idea. So that's one instance, but it's on a case-by-case basis. So, for example, the last thing that I showed you, the care centre, we protected the appearance of that and the layout of it, and we licensed that idea. Because one thing that we found is if you just do your research and come up with your design and then just release it into the wide world, and there's no protection around it, often people won't take it on because it makes more sense for a company to take on something with protection, with tangible intellectual property that they can then exploit. So we actually protected the design in this case, and then we licensed the idea to the manufacturer. So they see that there's merit in the design, and we see a small return in every time one is sold. But it's not a huge money-making process.
Okej, czy jeszcze jakieś pytania?
How many designers were involved in this process, and how long it takes?
The different numbers, and so for the first project, the Design Bugs Out project, I was 3 designers for 1 year. The second project, 2 designers for 2 years, and the third project, 2 designers, 1 clinician, 1 psychologist, and a business expert, and a whole load of academics supervising for 3 years.
Okej, chyba już nie mamy za bardzo czasu na pytania. So, thank you very much, Jonathan.
Okay. Thank you.